Hi, come along. It's snowing and not very pleasant here. Let's go inside my workshop. Quite a lot of warmth there. Hello. Yeah, so today it will be one more book for this rotating vane compressor. This time there will be three precision recesses. They are not through holes, they are recesses, so they are blind holes. And the normal 8 bolt circle around and so on. So well, let's see how this goes. Yeah, let's see how this goes. We are going to first work in the lathe. I have now dialed this workpiece in so that it is level this way, so that it's running straight. It's not wobbling. It should be within 1/100th of a millimeter. We have some deviation there, but not a lot. I need to set up my dial indicator the other way around. There. This is not running straight, not at all. I believe I already checked for. Okay. Now, recheck that we didn't generate wobble there. Like that. Hopefully we didn't. Huh. No, it's okay. It's okay. We have a pin here, and now I will do a coarse adjustment to find the center point by just visually seeing that this needle goes into the center. Well, I already did it. Well, it's quite accurately there. And why this? Well, then it's easier for me to deal with the actual indicator, which is this dial test indicator. It's here for, at this point it's 14, 14 and 14. Wow! Well, next we drill 4mm holes into that one. Well, the 4mm holes are ready. Next, I will change here. Well, first I will clean up this mess. Oh man. Well, these rubber sheets contain these chips, so they don't fly all over my workshop. That's really nice. And now I'll change this drill to an 7.75mm end mill. Now these holes will be 6mm deep. Well, yeah, next step, just make them. Well, okay, now the recesses are ready. Well, let's clean up here a little bit. Now I will change this end mill to a 3.3mm drill. And now let's just drill those. Now those holes are ready. Next there will be 2 oil passage holes. Well, I first take care of these. Yeah, 7.1. Now, this also suffices to be 15 millimeters deep. So, well, now we make two holes, one here and another there. Yeah, 15 millimeters both. The oil passage holes are now ready. Well, let's see. Next I will again clean up here a little bit. Let's now make this hole, and then we will be having another hole on the opposite side, which is 3 millimeters offset from the center. Well, now I switch this drill over to 8H8 reamer. Let's see now. Well, a little bit fast, but not a lot. Maybe 100. Well, that's okay. And a lot of oil. Yeah. Let me zoom you in again. The next step will involve a lot of deboring. Let's see how this looks. Let's zoom out you a little bit. So we can now dismantle this. Yeah, wow. A lot of it's oily. Yeah, well, looks like this. Now I will debur this, clean this up, and then I'll come back. Now I have deburred this workpiece, and it's ready for milling two accurate recesses here. They must be accurate in depth and in diameter. The nominal depth would be 5 millimeters. However, I will mill them 2/10 of a millimeter deeper. And then in the lathe I will peel off from the surface so that we end up being the correct depth. Well, let me show you something. Here is a place where you don't have too many pecker marks in this milling table. Then I have this 8 millimeter pin. You see I have drawn a line there. And then we have that hole, which is also quite near 8 millimeters. Now when I put this here. Yeah. And now if I hold it really. So now listen. Yep. So this surface is flat, and that hole is really accurate. Okay. Next, what we need is some sort of a measuring instrument. No, it's hanging quite long from there. Let's see how it does. When it touches. No, there you are. And now I zero this one. Okay. Then we plumb in 5 millimeters. Wow. The speed seems to be alright. We need some oil, cutting oil, I believe. So not 5 millimeters, we are plumbing it 5.2 millimeters. Let's see. And I will do this really manually, so. Okay, now we are over 5. So that was 5.1, 5.2, 5.3. Yes, I will go to 5.5, 5.4, and finally 5.5 there. There. Then just pull it off from there. Well, it certainly looks really nice. Okay. So, first, well, this is not the actual recess, this is just a good start for a recess. So now I will do the same for the other one as well. Yeah, okay. The Wohlhaupter setup. Well, of course I have this dial indicator here to measure the depth. And then the blade of this boring, planing head is pointing to wrong direction. What this means now is that when I want it to become, the hole become larger, I have to dial smaller figures here. So it goes like in reverse direction. This is intentional this time. The reason for this is that when I'm finished with the diameter, I want to make the bottom really plain. I can use the feed feature of this boring head. It feeds to the towards the bigger figures. So it will actually go from the outer rim to towards the center here inside. And now I'm taking off, I think 0.3 millimeters maybe. I don't know. I will now, when I have done the first one, I will then measure it and see where we really are. So let's start with this one. Okay, now the diameter should be quite exactly 19 millimeters. And it is 5.55 millimeters deep. But the bottom is uneven. And now, lucky us, we have this Wohlhaupter, we can do planing for the bottom. So, first things first, let's see that this is now locked, okay. This knob here, now, it just locks this ring, these two rings together. Now they are disengaged. Then I have a button here in the back which I pushed on. So now the feed functionality is on. So now when it starts turning and I stop this ring with fingers, it should feed in. It should. Well, let's see. Just checking the room there, that we have enough. Yeah, we do. I don't want to stumble into the wall. Still a few millimeters to go. That's enough. Let's see if it is. Yeah, it is. Okay, done. Ooh. We still have 1 millimeter spare. This is now 20 millimeter end mill, and well, I will just plumb it 10 millimeters deep. It's quite a heavy cut, a wide cut. This might shatter, I don't know. I'm running it something like 100 revolutions per minute. Yeah, so let's go. So there is our 10 millimeters now. Wow. I already planed the bottom. There was a little cone there, so now it's plain. Well, it helps in the future when I do the final planing for that one. So now I'm at 20.37 millimeters in diameter. I will first now do a rough milling. I will take 0.5 millimeter cuts until we are at 23 point something. And after that I will start really checking the diameter, where are we. So first I will now do some rough milling here. So now, after a little bit of milling, it's now 23.1 millimeters in diameter. And now I'm going to take here 0.5 millimeter from diameter pass, after which we should be somewhere around 23.6. And the last 0.4 millimeters I will also take in one pass. I don't like to split it, because this boring head, not head, the boring bar tends to I have a chip evacuation problems here. Well, yeah, okay. But let's take this past first and see where we are after that. I will measure it. Let's see that you are in the frame. Yeah, I knew this will go away from the frame. There you are. This one was a little bit easier to measure because it's deep enough. Okay, I will put it in a way that you can see it. So I do it like this, so it... let's do this again. Okay, now it is. So there is definitely a tension now in the pin. So then I just push it here very gently until it sort of drops like that. And then let's measure it. I don't know whether you see this, but okay. So it's quite exactly 23.6 now. Yeah, maybe 100 under. So now I go back. Boo. Off the frame you go. And now let's turn it so that you can see me dialing this in. Yeah. Okay, so we need 0.39 maybe. Okay, so 0.1, 0.2, 0.3, and now do we compensate for that 0.1 millimeter? Oh well, yeah, let's do that. On the other hand, if it is too small, wow, that would be now, I'll take it, it's better to be 1/100th of a millimeter too large this time. So now it should be quite exactly the correct dimension after this pass. So now we go back there. So now this is the last pass. Okay. There we go then. Yeah. Now, the next step will be to plane the bottom. Okay. Now it's 1/100th of a millimeter. Let me show you what I'm doing here. Let's widen this a little bit so that you can see. There is a good point. Okay. Now, when I grip this ring here, it starts to feed in the blade, like that. There you are. So now it's done. And let me. Ooh, what a nice finish we have there. So now this bottom here, that one, it's really in a very good condition. Well, here is my Tapmatic 50X tapping head. It's an automatic reversible tapping head. And now, well, how to attach a tap into one? Well, it has these collets. This is with steel, tapered steel things, and it goes there, and when you squeeze it, it will squeeze around this. Okay, so first you have the collet inside there. You don't need to open this, I just opened it to show you what's inside. Oh yeah, okay, yeah. So, and then we have here a hole. That hole serves for looking inside or looking through, so that you can see that the tap end is at the correct place. Okay. Yeah, and then there is this. It's sort of a vise inside there. I don't tighten it fully yet, because I need to center my tap here, and I'm using two wrenches here, one here and another around here. And I hope this goes all the way through. I check through the hole that it's still there, yeah, because it needs to be in place. Okay, now this is fully engaged. Although it seems to be solid in place, it's not. You have to use this, tighten this here, and this should be tightened after you first tighten this collet and then this one. And there you are. Now it's there. Well, this here is my drill press nose, the quill. And well, and this is in this case Morse 3 taper. I put it there. Try to be careful not to break the tap in the process, and then you, well, I just search for the slot where it goes into, and then I bang it there. There you are. Then we have, hopefully you can see this. Yes, you can. This one is used for the reverse system. I have here a dedicated piece of iron which goes very comfortably into there, and then it goes against that thing there. And now, there you are. The next step is to check your brake. Well, this has a brake. And well, you can check it by trying to turn it against its will, so to say. Wait a minute, I'll look for it. There you are. When you turn it, the tighter you, this is the brake here up. Can you see it? Yeah. The tighter you tighten it, the harder it breaks. So now, well, you can test it by turning this like this. And you should, it's estimation of your, if I loosen this, well, let's say that much, this becomes considerably looser. So I can tighten it a little bit like that. And yeah. So it's very delicate operation to adjust this, well, it's a torque limit. Well, we are going to need it today. Yeah. Okay, but basically it's installed now with all the bits and pieces we are going to need here. Oh yeah. Okay, now how to attach the workpiece into this one, and I had a lot of thoughts how to do this, but I finally ended up in pins. So, well, it's these holes we need to tap, and those holes are 15 millimeters deep, and they are blind holes. So, yeah. And that's why the torque limiter is needed here. So I decided to use a pin here. This is a very exact 8 millimeter pin. Goes into there. And then you have it on the bottom there. Now you can rotate it here, like this, to have the next hole available. It doesn't have too much wiggle on vertical, but what you have to be afraid is the, well, how would I say it? Did this? Oh yeah, okay. And this is a 4 millimeter pin. And now when I lock it like here, it won't rotate to the direction which this is trying to rotate it. Because it's going to be very hard to resist that one. So then I just, for every tap, I come here and locate the hole like this. It doesn't need to be precise. That's plenty much of accuracy. And then I tap it. Well, that's about it. Well, and well, the danger here is if it moves too much, it will bend this tap, and if there's anything that will really break your tap, it's bending it. That's one way to break them really quickly and with minimal force. Yeah, okay. It's Weiler time. Well, yeah, this time it's just, well, I'm going to face this. Then the inside is bored to 14 millimeters. Well, not bored, like bored and reamed. The 14 millimeters, and the outside is turned to 24 millimeters. And then it's parted off at maybe 11 millimeter length. That's it. So let's go. Wow. So we have half a millimeter, actually quite exactly to take off from it. A bit of a lucky this time. So, one more time. Because, yeah, I would like this to be a little bit, how to say, loose. Yeah, it's undersized. Good. Very good. Well, I actually will take it even a little bit more loose. But let's say now, half a millimeter. That's a half a millimeter, but yeah. And maybe 200 more, like that. And then, well, I think we are. This is now final pass. Well, let's see. It should be quite exactly 24 millimeters now. Actually, 200 or so undersize. Well, it's 200 or so undersized 24 millimeters. Yeah, good. Sometimes you get lucky. Well, maybe not just lucky. I'm using automatic feed, but it's really slow feed. It's the slowest. 0.038 millimeters per revolution. Well, this takes some time. Well, it left a horrific burr there, but well, that's nothing bad actually. Okay, now next thing I will do off the camera, I will glue this into the workpiece. an 8mm pin. Very simple. Oh, this is slow. Oh. Yep. Let's take my parting tool from the cabinet. Here you are, parting tool. And there we go. There you are. Parted. And now I will glue this also to the workpiece. This is now the last operation for this workpiece, and this is to level both sides. This side just level it. The dimension is not that critical. It just needs to be really level. All these things that are now protruding, coming out from the surface must be leveled so that it becomes a level surface. The other side, however, needs to be precision done so that the recesses there will become to exactly 5 millimeters. That will be, well, when I turn this workpiece around, so then you will see. But let's first take care of this side of the workpiece and just do it. So I'm feeding this first manually. I'm using this VNMG insert to get rid of those. This is sort of interrupted cut. So lock the carriage and then feed in by the top slide. And now I try to zero my top slide. Just touch. Okay, now we go. Wow. That surface leaves nothing to wish for. Now we go and turn this workpiece. We have a similar issue at this side. Well, it's imperative to clean these surfaces. You don't want any chips in between there. That would be disastrous for the accuracy. And now it really doesn't matter which orientation this sits there. The main thing is that it sits there. There you are. Yeah, okay. Oh, let's just do it. Okay, now we are ready for the precision turning. This is now, we had 0.6 millimeters, I believe, extra in there. Well, I will actually measure it now, but I will also change the tool. This is too coarse for this operation, and well, wipe clean this also here a little bit. We have 5.53 millimeters at the moment here. So what I would like to do now, because we are using the compound for this, so I will attach here a dial indicator. How come? Well, now I'm going to peel off this until we have the 5 millimeters left there, and I try to be as accurate and possible. I will now change to a different mode of filming, because I don't want to talk and film at and do my job at the same time. It seems that I fail when I do this, so therefore I will now case talking and just do the turning. So now it's starting to be the moment of truth. So when I measured it with my depth mic, it was 5.21 actually, quite exactly that. And now I would like it to be 5 millimeters, so we need to peel off 0.2 millimeters or 0.21 millimeters from that. And now I won't do that in one pass, I will do it in two passes. So now let's take the first 0.1 millimeters. It's like there, I believe. Yeah. And then I turn this, and then I do measure it again, and whatever is left I will then peel off. Yep. Well, I got it very near to 5 millimeters. Actually, it's very difficult to get any nearer than that. Okay, now this needs some deboring, and there is one thing that you shouldn't do with this one when deboring. Yeah, you should debor, but you shouldn't chamfer. These edges here should be left unchamfered. You can remove the burr if there is any. Well, actually that kind of turning process I used doesn't create a lot of burr. It peels off very gently, and this tool is really sharp. So, well, I believe I'll leave it alone. That's probably the best thing to do. Maybe those threads, because when you put a screw in there, it will pull the last thread out if it's not chamfered. So those I will do, those I don't. Others I leave alone. Maybe I just wipe it with some stone, so that if there is any burr, so it comes away. But other than that, I leave it alone as much as possible. So now there is still one thing to do with a drill, and that's exactly the next step we are going to do, but it's not in the lathe. Well, this is the last operation for this workpiece. Drilling a hole to pass oil from this oil pump into the rotor. And now, which hole? We have two here, candidates. One is sucking, and one is the in, and one is the out. And it depends on the rotating direction. In this case, this is the back side, and I designed this in a way that it is rotating clockwise. So this is, because it's the back side, it's rotating counterclockwise, so this way. So that gear will be rotating this way, so the pressure side will be the one in the back. And now I of course, I did already align my drill. So now this is a very delicate operation, and hopefully I don't break this part now. Okay, it's true. Gripped as always. It does. Wow. A lot of stuff from there. Well, wow. Let me clean this up. Okay. And here it is, the hole. The other is blocked, that one, because it's sucking oil into this one, but this is now through, into here, and this one I think I can chamfer if I want to. Well, a little bit. But there it is. This is now a ready to go part. There is no more machining to do for this part now. Well, yes, we succeeded in this part. Didn't make any mistakes, I believe. No, yeah. And it became a good part. In the next episode of Finno-Ugric machining, well, we are going to make yet another book. That will be a short episode, but it will be another book with 8 holes and, well, 1 oil channel in that one. But that's in the next episode of Finno-Ugric machining. Well, and now, I'm going to use my magic file. Oh, no. This is my magic file, so... Okay, bye!